Hello everyone, this is Dr. Prashanth and welcome back to Public Health series. In this video, I'll be explaining paid t-test with a numerical example. So I took an example from previous year paper, so I'll just go through the question briefly. 7 preschool children were given a nutrition supplement of Balbog under ICDS for a period of 6 months. The skin fold thickness in mm was measured before the program and also at the end of 6 months. The values are given in the following table. So they are asking you to calculate the statistical test that can be applied in the above data: mean difference, standard error, degree of freedom, t-value and p-value interpretation. So before calculating those values, it is very important to understand what type of statistical test is applied in the following data. For that, first we need to check the total number of groups. So there are two groups before and after supplementation, right? And these two groups are paired. Why? Because data is collected from the same children at different times, before and after supplementation, but the children are same. Next, we need to see what type of data is the outcome data. So in this question, the outcome data is the skin fold thickness in mm. So it is a continuous data basically, right? 6, 7, 8 mm. Other examples include height and weight. So for comparison of two groups of paid data, we use paid t-test. Now let's look at other common statistical tests. First is independent t-test. It is used to compare two independent groups for continuous outcome. Chi-square test for two independent groups in case of categorical outcomes. ANOVA test for more than two groups where the variables are continuous. And if you want to see the relationship between two or more continuous variables, we use correlation and regression analysis. Now coming back to question, in step 2, we need to calculate the test value, that is t value. So the formula is mean difference divided by standard deviation divided by square root of sample. Or in other words, it can be mean difference divided by standard error. So for that, we need to calculate the difference between the skin fold thickness values of each child. So we just need to simply subtract the skin fold thickness of each child. For example, for child number 1, 8 minus 6, next 8 minus 8, similarly 10 minus 8, 9 minus 6, 8 minus 5, 10 minus 9 and 9 minus 6. So after doing that, we need to calculate the mean of those differences, okay? So it's nothing but we need to add all the differences and divide it by the number of samples or number of children. It is nothing but 7 in the denominator. So it's 14 by 7 and the mean will be around 2. Now we need to calculate the standard deviation, and the formula is in the numerator, it is square root of d1 minus mean whole square, that is difference 1 minus mean, plus d2, that is difference 2, similarly till d7, okay? And in the denominator, it is square root of sample size minus 1, that is 7 minus 1. So if you do the calculation, you will get the value as 1.155. It is nothing but the standard deviation, right? So if you want to calculate standard error, the formula is standard deviation divided by square root of sample size. So we have calculated the standard deviation, right? It is around 1.155. So divided by square root of 7, that is the number of children. So the answer is around 0.43. That is the standard error of the differences. Now we calculated both the numerator and denominator of the t-value formula, right? So in the numerator, the mean difference is 2, which we have already calculated. And in the denominator, the standard error is, we already did it, 1.15 divided by square root of sample size, that is 0.43. So 2 divided by 0.43 is equal to 4.6511. So the t-value, that is calculated t-value, is equal to 4.65. Now coming to degree of freedom, for paid t-test, the formula is n minus 1. N is nothing but the sample size or the number of children in this case. So 7 minus 1 is equal to 6. So the degree of freedom is equal to 6. Now let's look at degree of freedom formulas for other statistical tests, okay? So chi-square test for independence, it is number of rows minus 1 multiplied by columns minus 1. For chi-square test for variance, it is n minus 1. For one sample t-test and paid t-test, which we have done now, it is n minus 1. For independent two sample t-test, we have two different samples, right? So n1 plus n2, n1 and n2 are the size of different samples, sample 1 and sample 2, minus 2. That is the formula of degree of freedom for independent two sample t-test. ANOVA between groups, the formula is number of groups minus 1. ANOVA within groups, to see the variation within the groups, it is total number of observations minus number of groups. Now coming to step 3, that is p-value calculation and interpretation. We need to use the calculated t-value and the degree of freedom to check the statistical table. So the calculated t-value is 4.65, right? And the degree of freedom is equal to 6. That is nothing but n minus 1, 7 minus 1. First, look at the table and try to understand. On the left side, they have given the different degrees of freedom, that is from 1, 2, 3, 4, etc. And in the columns, they have given the significance level, that is 0.05, 0.02, etc. Along with that, they have given one tail and two tail, okay? But in our question, they didn't mention anything about it. So in the alternate hypothesis, we will just take as the mean of skin fold thickness of both the children are not equal. We are not saying one is better or one is not better, right? So this is a two-tailed test now. So, and if they have not given the significance level, by default, we need to take 0.05 as the significance level. So first go to the degree of freedom level side, that is 6, and check horizontally till you match the significance level of 0.05 for two-tailed test. So the value is around 2.447. So this is called critical T value, which we got from the table, right? So T critical value from table is equal to 2.447. So how to interpret it now? Because there are basically two rules for that. First is, if the absolute value of a calculated t value is greater than the critical value, then we reject the null hypothesis. And if the absolute value of the calculated t value is less than the critical value, then we fail to reject the null hypothesis. So in our example, the calculated t value, that is 4.65, is greater than the critical t value, which we got from the table, that is 2.447. So we reject the null hypothesis. And when do we reject the null hypothesis? When the p-value is less than 0.05. So I have given the p-value interpretation table. If the p-value is less than 0.05, we call it as statistically significant. That means there is sufficient evidence to reject the null hypothesis and accept the alternative. If the p-value is more than 0.05, we say it is not statistically significant and there is insufficient evidence to reject the null hypothesis. I have given two practice questions for you. You can just post those answers in the comment section. And for the practice question number 2, always keep in mind when I use the word absolute value of a critical t table or absolute value of a calculated t value, we should not consider the negative sign. Okay. I hope it is very helpful. Thank you.